So in this video, we are looking at using trigonometric formulas. The trig formulas that we have in mind are the formulas that you find on your reference sheet. You should have one of those, and you'll find this reference sheet on the back page of the Regents exam as well. So since these formulas are on the reference sheet, you need not memorize them, but you have to be comfortable with them, and you have to be able to choose the correct one when you need it. So take a look at this example. It says, find the exact value of the cosine of 15. What does it mean when it talks about the exact value of the cosine of 15? Well, I'll show you what is not an exact value. If you just use the calculator and you type in cosine of 15, it gives you this long decimal number. This decimal number is really an approximation of the cosine of 15. It's not an exact value. We can do better than that by using one of these formulas. You see, I do know exact values for 30 degrees, and I know exact values for 45 degrees, and I'd like you to notice that 45 minus 30 is equal to 15. And that means in order to find the cosine of 15, I could also find the cosine of 45 minus 30. So said another way, the cosine of 15 must be the same thing as the cosine of 45 minus 30. Now, is there any trig formula which is the cosine of two angles being subtracted? So we look on the reference sheet, and I notice that right here there is the cosine of A minus B is equal to this. So I'll take this and write this down for you. From the reference sheet, it tells us that the cosine of A minus B is equal to the cosine of A times the cosine of B plus the sine of A times the sine of B. What is the A going to be in this case? You see the cosine of A minus B, and here we have the cosine of 45 minus 30. Yeah, the A in this case then must be our 45, and the B in this case must be our 30. And now we can go ahead and just make these substitutions. After all, trigonometry is really a great big exercise in substituting. So the cosine of 45 degrees times the cosine of 30 degrees plus the sine of 45 degrees times the sine of 30 degrees. We just made those substitutions, the A's and the B's, based on what we have right here and using this formula. But we can go a step further, because we know the exact values of these, since 45 and 30 are special angles. If you don't have these memorized, you need to start memorizing these now. So the cosine of 45, that's radical 2 over 2. The cosine of 30, that's radical 3 over 2, plus the sine of 45, that's also radical 2 over 2, and the sine of 30 is 1/2. Now we need only simplify. We've done the substituting, and now we're going to simplify this. Radical 2 over 2 times radical 3 over 2. You multiply the numerators together. Radical 2 times radical 3 is radical 6. And then you multiply the denominators together. 2 times 2 is 4. Bring down this plus sign. Radical 2 times 1 is radical 2. And 2 times 2 is 4. So we have radical 6 over 4 plus radical 2 over 4. These are not like radicands. Radical 6 cannot be broken down any further. The best we can do is write it out as one fraction now. So we have radical 6 plus radical 2. They cannot be combined since they're not like radicands. The common denominator here is 4. And so this is really our answer. We can say that the cosine of 15 is equal to radical 6 plus radical 2 all over 4. In fact, let's check that. Earlier I showed you on the calculator this approximate answer. The cosine of 15 is 0.9659, etc. Let's type in what we have here very carefully using parentheses to make sure that we do the correct order of operations. So this is parentheses, radical 6 here, and then we got to add, oops, I'm going to clear this out. So there's our radical 6, and then we would like to add to that radical 2. And then we can close this parentheses, and we'll divide that all by 4. There's a bit of a glare in the screen, so I'll move this over here. We see this is radical 6 plus radical 2 divided by 4. That's precisely what we have written down here. Notice how we used parentheses to avoid making a mistake with order of operations. We press enter, and it's showing us the exact same approximate answers. This is a good way of checking to see that we have done this problem correctly.